Hello everyone, I am Reshma Totare, working as Assistant Professor in Information Technology Department. In today's session, we will discuss about Dynamic Host Configuration Protocol. Each computer that uses the TCP/IP protocol suite needs to know its IP addresses. If the computer uses classless addressing or is a member of subnet, it also needs to know its subnet mask. Most computers today need two other pieces of information: the address of a default router to be able to communicate with other network, and the second one, the address of a name server to be able to use names instead of addresses. Four pieces of information. First one, the IP address of a computer, the subnet mask of the computer, IP address of a router, and the IP address of a name server. These four pieces of information can be stored in a configuration file and accessed by computer during the bootstrap process. Before DHCP became the formal protocol for host configuration, some other protocols were used previously. The first protocol, RARP, Reverse Address Resolution Protocol. At the beginning of Internet era, a protocol called Reverse Address Resolution Protocol was designed to provide the IP address for a booted computer. Second one, Bootstrap Protocol. Bootstrap Protocol is the pre-runner of DHCP. It is a client-server protocol designed to overcome the two deficiencies of RARP protocol. First, it is a client-server program. The Bootstrap Protocol server can be anywhere in the internet, and the second is it can provide all pieces of information including IP addresses. Third protocol, DHCP, Dynamic Host Control Protocol. DHCP is a client-server protocol designed to provide the four pieces of information for the diskless computer or a computer that is booted for a first time. Now we will see the DHCP, Dynamic Host Configuration Protocol operations. There are two types: client and server both are on the same network, and the second one is a client and server are on a different network. First we will see client and server are on the same network. The administrator may put the client and the server on the same network as shown in the figure. In this case, the operations are: first operation, the DHCP server issues a passive open command on UDP port number 67 and wait for the client. Second step, the bootstrap booted client issues an active open command on port number 68. The message is encapsulated in a UDP user datagram using the destination port number 67 and the source port number 68. The UDP user datagram is encapsulated in a IP datagram. Now the question is how a client can send IP datagram when it is known neither its own IP address nor the server's IP address. The client uses all zeros as the source address and all ones as the destination address. Third step, the server responds with either a broadcast or unicast message using UDP source port number 67 and the destination port number 68. The response can be unicast because the server knows the IP address of the client. It also knows the physical address of a client, which means it does not need the services of Address Resolution Protocol for logical to physical address mapping. Now we will see client and server are on a different network. As in other application layer processes, a client can be in one network and server is on another network separated by several other networks. There is one problem that must be solved. The DHCP request is broadcast because the client does not know the IP address of the server. A broadcast IP datagram cannot pass through any router. Router receiving such a packet discard it. To solve the problem, there is a need for an intermediary, one of the hosts can be used as a relay. The host in this case is called relay agent. The relay agent knows the unicast address of DHCP server and listens for broadcast message on port 67. When it receives this type of packet, it encapsulates the message in a unicast datagram and sends the request to DHCP server. The packet carrying unicast destination address is routed by other router and reaches the DHCP server. The DHCP server knows the message comes from relay agent because one of the fields in the request message defines the IP address of the relay agent. The relay agent, after receiving the reply, sends it to the DHCP client. Thank you.